Welcome to The Explainer. Today we're diving into a piece of tech that sounds like it's straight out of science fiction, but it's very real, and it's already changing our world. We're talking about the digital twin, the idea of creating a perfect, living, digital mirror of pretty much anything around us.
Okay, just imagine for a second you had a crystal ball, but for anything. What if you could see the future of an object? You could test a jet engine in a virtual hurricane, or a surgeon could practice a complex heart operation 100 times with zero risk. Or what if you could fix a city's traffic jams before they even happen? This isn't magic. This is exactly what the digital twin makes possible.
All right, so to really get what makes this technology so revolutionary, we've got to break it down. What exactly is a digital twin? And just as important, what isn't? So you might be thinking, isn't that just a 3D model? Nope, not even close. Think of it this way. A 3D model is like a photograph. It's static. A digital twin, on the other hand, is like a live video feed with superpowers. It's a living, breathing digital copy that's constantly fed real-time data from its physical counterpart. It's this active, dynamic bridge between the real world and the digital one. The core idea, which actually came from Dr. Michael Greaves back in 2002, really rests on three main pillars. First, you have the actual physical object out there in the real world. Then you've got its virtual model, its digital doppelganger. But the secret sauce, the thing that makes it all work, is the third piece, the data connection. It's a constant stream of information from sensors that keeps the two perfectly in sync. It's what lets the digital version know exactly what the physical one is doing, second by second. Okay, so that's the theory. Cool concept, right? But where is this actually being used? The answer is pretty much everywhere. Digital twins are already working behind the scenes, totally changing how some of our biggest industries operate. Let's kick things off with manufacturing. Think about it. For a factory, everything is about efficiency and making sure the production line never, ever stops. Downtime is the enemy. Well, digital twins are basically becoming the ultimate co-pilot for factory managers.
And here's where it gets really cool. Predictive maintenance. So picture a giant wind turbine out in the middle of nowhere. That gearbox at the top, it's super expensive and a huge pain to fix. But if you have a digital twin of that gearbox, one that's constantly getting data on its performance, well, engineers can see a failure coming weeks or even months before it happens. This isn't guesswork, this is data. And that simple prediction can save something like $8,000 on just one turbine. Not to mention preventing all that downtime and dangerous repair work.
But the impact of this tech gets way more personal when you bring it into healthcare. Because now, we're not just talking about modeling a machine, we're talking about modeling a human being. Just imagine you're a surgeon about to do a really complex heart operation. Instead of just looking at standard models, what if you had a perfect digital replica of your actual patient's heart? You could practice the surgery on that twin over and over again, trying out different approaches, all in a totally risk-free virtual space. It's happening. And that same idea applies to testing new drugs on a virtual organ or designing a treatment plan that's made just for you. This is the future of personalized medicine right here. Okay, so we've gone from a machine part to a human heart. Now let's zoom out even further to the scale of an entire city. Because the ambition here is to create digital twins of whole urban environments. And when you do that, city planners get a powerful new tool. They can play what if with the city's biggest problems. What if we change this traffic light timing? Let's simulate it and see if it clears up that bottleneck. How can we make our energy grid more sustainable? Let's model it. They can even run simulations for emergencies to figure out the best way to respond. It's all about making our cities work better for us, safer, cleaner, and just smarter. So, the big question is, how does this magic actually happen? Well, a digital twin isn't just one thing. It's more like a team of technologies that have all gotten really good at the same time, and now they're working together. Probably the best way to think about it is like a body. It needs senses to see and feel what's going on, a brain to make sense of it all, and some kind of foresight to predict what's coming next. And there are three key technologies that play these roles. First up, you've got the Internet of Things, or IoT. These are the sensors. We're talking about billions of tiny sensors stuck on everything from a car engine to the concrete in a bridge, constantly collecting data, temperature, vibration, location, you name it. Okay, so all that data has to go somewhere. It flows to the brain, big data analytics. These are the powerful systems that can chew through mountains of information, find the hidden patterns, and spot the tiny anomalies that no human could ever hope to see. And that brings us to the third piece, the foresight. This is where artificial intelligence and machine learning come in. The AI takes all those patterns found by the big data brain, and it learns from them. This is what gives the twin its predictive power, the ability to see the future, anticipate problems, and even make changes on its own to keep things running smoothly. And just to give you an idea of the sheer scale we're dealing with, it's absolutely insane. By 2025, those IoT sensors are expected to generate almost 80 zettabytes of data a year. What's a zettabyte? It's a trillion gigabytes. It's a tsunami of data. And these systems are designed to surf it. But, a technology this powerful and this complex, it's not all smooth sailing. For all the amazing promise, actually building a digital twin comes with some pretty big challenges. So you've got this constant tug of war. On one side, you have the incredible promise. More efficiency, better safety, real sustainability. But on the other side, you've got the reality. It's expensive to set up. It's really hard to connect it to all the old systems a company might have. And of course, there are huge questions about keeping all that data secure. Plus, you need people who actually know how to build and run these things, and there just aren't enough of them. So even with those hurdles, where does this go next? Well, the vision is getting bigger and bigger. We're moving beyond just twinning one thing at a time and starting to think about creating these huge, interconnected digital worlds. It's really evolving in steps. We started small with a unit-level twin, like a digital copy of just a single bolt or one turbine blade. Then we scaled up to a system-level twin, modeling the whole jet engine or the entire wind turbine. But the really exciting next step is the system of systems twin. This is where you're not just modeling one turbine, but the entire wind farm, or even the whole power grid, with all these different digital twins talking to each other. And this really gets at the ultimate goal here, to build a complete, interactive mirror of our world. A simulation so powerful we can see not just how one part works, but how everything connects. How the power grid affects the traffic system, how that affects public transport, all in real time. That's where the truly game-changing insights are going to come from. Which leaves us with one last big question to think about. We've gone from a single engine part to an entire city. As this tech gets cheaper and better and easier to use, what's next? What will we choose to mirror? The entire global supply chain? A delicate ecosystem? A country's economy? Really, the only limit seems to be our own imagination.